So in this exercise, what you're asked to do is to draw curly arrow mechanisms for the above reactions. So we've got this reaction here, where we're getting a substitution of the bromide with the hydroxide to give the alcohol. This second one here, it's an elimination reaction, where we're going to remove a hydrogen and a bromine using a base, a sterically bulky base, to give the alkene. So for this one here, let's draw out our HO minus. That's going to be our nucleophile. This is polarized delta plus, delta minus. So what we're doing in this reaction is this will attack from the high electron density to the low electron density delta plus center. We will break that bond, and that will give us all of this chain is the same. So 1, 2, 3, 4, 5, 6 carbons. Now rather than having the bromine, we got the OH and we got bromine kicked out. So if you remember right back to the very beginning of the course, I said we have to balance both the atoms and the charge. So here we had a minus from the OH, so here we've got a minus from the bromide. So this would be a nucleophilic substitution reaction. This case here, we're using a bulky base, so T-butyl, let's just draw it here. So we've got K plus as the salt, and then we've got oxygen onto a T-butyl, so that's this one here, tert-butyl. It's obviously bulky. So this is going to be very bulky. It's going to be hard for it to actually approach onto a carbon. But what it can do is take a hydrogen from a less hindered position of the molecule. So I am just going to call that T-butyl O minus, but that's a full structure there. So in this one here, where we've got the elimination, that will come in, that will kick round, and that will kick out our leaving group. So again, we've got 1, 2, 3, 4, 5. That's all stayed the same. This is now fed the electrons in to make the double bond, and we've broken that off, so we get Br minus. So yeah, hopefully you're getting more familiar with drawing these. Always go from high electron density to low electron density. It's always what we're doing. And check that your atoms and your charge balance on each side.